Welcome to the Learning Pines YouTube. We hope this video helps.
You start by collecting the measurable inputs you need: loads, geometry, and material strength. First, list service and ultimate loads with directions and magnitudes so you can treat worst-case scenarios. Next, measure cross-sections, lengths, and any moment arms precisely. These feed into stress formulas. Then, choose appropriate material values, yield versus ultimate strength, and note factors like corrosion or temperature that reduce capacity. Once done, you'll be ready to compute stresses and compare them to capacity. You now compute the internal stresses produced by the loads you documented. Calculate axial stress as load over area, bending stress from M over section modulus, and shear stress from shear force and area. For complex parts, run a simple FEA. Then compute the component capacity using the chosen material strength. Apply reduction factors for safety or code requirements. Next, combine stresses with von Missy's or interaction equations so you have a single demand number to compare against capacity. You finish by dividing capacity by demand. Factor of safety equals the selected material strength divided by the applied or combined stress. If you used yield, explain why. If ultimate, justify plastic behavior assumptions. Once done, compare that FOS to code or project requirements and decide whether to reduce load, increase geometry, or pick a stronger material. Make sure to document assumptions and run a quick sensitivity check. If results are unexpected, recheck input loads and boundary conditions. Those are the usual errors.
Thanks for watching. Consider subscribing if we helped you.